All right, so I'm not going to read the question because you all can take the time to do that. So for a melon selected at random from distributor J, what's the probability? As soon as I see the word probability, I know that I need to look for the type of distribution. But they want to know whether or not it'll be greater than 137. So we're looking for the probability that X is greater than 137. So I need to figure out what type of distribution. And when I look up here, they tell me it's normal. As soon as they tell me it's normal, I'm going to write down Z equals X minus mu over sigma and see what other information I have. So I see that the mean is 133 and the standard deviation is 5. So I'm going to go ahead and draw my little diagram. My little diagram says we're centered here at 133. We know we have a spread or standard deviation, in this case of 5, but we want to be greater than 137. So this will be 137, and we're going to shade to the right and go to the positive infinity. So I'm going to start plugging in to see if I'm missing anything. And I go probability that Z is greater than or equal to 137 minus 133 over 5. Well, I have everything I need to know, and so I'm going to go ahead and simplify to find Z, and I go probability that Z is greater than or equal to 0.8. So now I'm going to go to my calculator, and because I'm looking for probability, when I look for the probability and it's normal, I go second vars, and this will be a normal CDF. My lower bound from the shading is 137, my upper bound is infinity, my mean is 133, and my standard deviation is 5. And I find out that I have about a 2.2119 probability of that occurring. So 0.2119 chance of finding a melon from J that is greater than 137, and that's our answer. All right, part 3 says, for a melon selected from random from the grocery store. The problem here is we have two grocery stores. We have we have two distributors to the grocery store, K or J, and we don't know which one melon that they're drawing. And I still want the probability that it's greater than 137. So we basically have two categorical variables. We have diameter of the melon, and then we also have the distributor. So I'm going to label this distributor J and distributor K, and I'm doing that because they tell me that 70% of the melons come from J. Well, there's no condition on that. It's not related to two variables, so I can write that down just the way it is. Well, if that's 70%, then this is 30%. Obviously, it sums to 1. Now, this is a bit picky, but AP really wants us to label that as total, so we need to put total, make sure that we know that we've labeled our totals. Well, the other categorical variable was whether or not it was greater than 137. So this one is just going to be greater than 137. And this is going to be less than 137. With the contingency table, we take our values at the bottom and we write them small, but we bring them up in each column, in the respective columns. So this is going to be 0.30, and this is 0.30. Well, I need to know the probability that a melon is greater than 137 or less than 137 if it comes from K. Well, they tell me that is 0.8413. So this is going to be 0.8413, and the value below it is going to be 1 minus 0.8413, which happens to be 0.1587. I can go ahead and multiply those values together, and when I do that, this becomes 0.2539, and this becomes 0.04761, and they should add to 30% if I've done my work right. Well, the probability that it came from J and is greater than 137 is 0.2119, and I know that because we calculated that in part A. So the complement that is less than that is 1 minus 0.2119, and that is 0.7081. When I multiply those values out, this sums to 0.14833, and this sums to 0.55167. So summing across, This is 0.40072. And summing across, this is 0.59928. And if I've done everything correctly, these two together will sum to one whole. Now, part C says, given a melon selected at random from the grocery store has a diameter greater than 137, what's the probability it'll be from distributor J? Well, as soon as they tell me given, I go, oh, given goes in the denominator every single time, and the intersection goes in the numerator. So they're telling me, given that it came from distributor, given that it was greater than 137, well, my given is right here. So I know that 0.40072 is going in the denominator. And then my intersection from J, oh, it's 0.14833 because that's where the two intersect. That's in the numerator. When I divide that out, that equals 0.37. So that would be my probability. Thank you very much.